Okay.
So just to track my progress, did you guys get a personal email from Sister Withers?
Yes.
Yes, I think so.
Okay,
And
good.
I think it seemed like she sent to us all the same.
Probably, I imagine, but I just want to make sure it wasn't like, Jake, how are you doing?
Slacker.
Like I was in trouble or something, I guess. But it's all good. So what's his name?
Okay. Dad's leaving, so go with him. Okay.
So Lexi, what did you name him?
Lucy.
Is it? Oh, I'm sorry, Lucy. Her.
Well, that's
Okay.
Lucy, that's cute. Cute name.
thanks.
Cute name for a cute kid.
Very fun.
She's fun.
All right, so how many problems? We've got 21 tonight.
Yeah.
That's not pretty easy.
Okay, so number 3, which hypothesis involves equality? That is the null, right?
Yeah.
Okay.
Okay.
Or the alternative.
So for 4, would this one be the null too?
I thought it was alternative.
See, I didn't know.
I thought you only did the p-value if you were trying to prove that the null hypothesis was wrong or different. I'm
No,
open to
that's-
learning.
I don't know this one. I always thought that you were supposed to accept the null hypothesis as true unless you eventually prove it otherwise.
Right.
So I'm leaning towards the null since you're like working on a value, but I don't know.
Because I thought when you do the p-value, then you compare it to the what's it called?
It
So
says the
Alpha.
value is determined using the alternative hypothesis. If the alternative hypothesis is two-sided, then the p-value is the area in the tails that furthers. So maybe it is alternative.
yeah, so I want to say it's alternative as well.
If the alternative
I'm pretty
hypothesis
sure.
involves less than, we call it left tail, the p-value is under the, yeah, I kind of think it might be alternative.
Okay.
I'm pretty sure.
All right.
Let's
So
see. P-value probability. Oh, wait. The p-value is the probability of obtaining a test statistic at least as extreme as the one you calculated, assuming the null hypothesis is true.
Okay.
In other words, our p-value is the probability that we would get a z-score that is extreme or more extreme than whatever.
So we are assuming that the hypothesis.
So maybe it is the null hypothesis?
Oh my
I think that sounds like the null.
It is. Because it says assuming the null hypothesis is true, and that's what the question's asking.
Yeah, I guess that's true because you would assume that it's true and then try and prove.
When you're computing it. So when you're computing it, you're still working on it. You haven't arrived at any conclusion yet.
Okay.
Should be
Yeah, that
assuming
must be.
null is true.
Okay. So for 5, which of the following represents a two-tailed test? So would it be C or the?
The line through the equals.
Yeah. Okay. Which of the following represents alternative hypothesis for a left-tailed test? I had the first one.
Mm-hmm.
First one, yep. Okay.
And then 7.
The second one.
Yeah.
Second one, okay.
Remember that we determined the outcome. So which relationship would result in failing to reject the null hypothesis? So wouldn't it be the less than? Because if the p, what was it? If the p is low, then you reject the null. Oh, no. So then it would be the first one is the greater.
Yeah, you had it switch.
Switch, sorry. Okay, the next one.
Yes,
Is-
it is less than.
Okay. So the 8 is the first one and 9 is the second one.
Yeah.
Right?
Okay.
Alright.
Which of the following would be appropriate? Alternative hypothesis.
I got C. Greater than 15.
That's what I got too.
And that's where I left off.
Is that what you guys think? Rachel and Jake?
Yeah, no, that makes sense. That would be greater than.
Okay.
So 11. Which of the following would be appropriate? Null hypothesis. I did the first one.
Claim is equal to. Okay. Yeah, that sounds right.
Mm-hmm. Mm-hmm.
12.
I did that it was a good assumption because the sample size was 40. So the sample size is large enough.
Good assumption. So the first one, yeah. Okay.
Good with that.
13.
So I got the central limit one.
Yep.
Hmm.
Sounds good.
Okay, which of the following is the test statistic? Isn't that the first one? That X with the line on it? I didn't know for sure.
Let's see. That's the value.
Or would that be
The value.
Z?
I think it's Z.
Sorry, guys.
Oh, did you disappear?
Yeah,
Oh.
my internet went out.
Oh, sorry. Where did you leave off? What number did you leave off on?
11.
11. Okay. So
So,
we
But
did the
it's equal
first.
to?
Yeah, equal to.
Okay.
And then
Sorry.
12, we did the first one that it was a good assumption because the sample size is large.
Okay.
And then we got the central limit theorem for 13. We were just talking about 14. I think it's Z. What do you think, Jenna?
I think that's probably right because I guess the X with the line on it would be the,
The value. And then the
Uh-huh.
ends the number.
yeah. So I think you are right.
Deviation, so I think it's got to be Z.
You guys are all frozen again.
Oh,
Oh,
My internet is so bad. Well, all of Rexburg's pretty down right now, so. Problem.
can you hear us at least?
Yeah, sometimes. I'm still back on 13.
13.
Where
So
are you
13,
guys at?
we central limit theorem. We're just getting done with 14.
what did you think 14 was, Jenna?
Which of the following is a test? Oh.
We were thinking that it was Z. How do you feel about that?
Yeah. I don't think it's any of the other ones.
Okay, that sounds good. I didn't think there was even an S.
Yeah, I think it's made up.
Okay.
Oh, that's right. The standard deviation is the sigma sign. Okay.
Okay, so then for 15, I got an answer, but I don't know if it's right. I got negative 0.025.
You were good.
Let me know if anyone gets that.
Okay.
Oh wait, never mind. Now I got a different one. I got negative 0.9.
Okay, I'm almost done.
Okay, yeah, I got negative 0.9.
Yeah, I got negative 0.9.
Okay. So then the p-value, we put it into the normal applet.
Except for it says round to 3 decimal places.
Uh-huh.
So
Oh. I think you just leave it. Unless, I think you just leave it at 0.9.
Yeah.
So when it says what is the p-value associated with the z-score, so don't you put that into the normal probability, but then what do you shade?
you shade what the question is saying.
She thinks it's
That it's decreased, so you would highlight the left.
Oh, decrease.
Yeah.
So 1/8.
well, I got 0.5359. 0.536. Is that what you guys got? Oh wait, never mind. Hold on, I messed up.
I got 0.184.
Yeah,
That's what I got.
You're right. I messed up on the number.
So what inference could you make about the null hypothesis? So if it's 0.1, so it would,
Wait, what'd you say about it? Sorry, 8.16?
I got
0.184.
Yeah, that's what I got.
What am I doing wrong? So you
So
put
you
it
just highlight the left part of the normal probability and then put negative 0.9 as the z-score on the left.
for 0.09. Oh, I'm still getting.
No, it's just 0.9.
0.9, negative 0.9.
Negative 0.9.
And then we shaded to the left.
1.84. Okay.
0.184.
0.184. Why do I always mess up on that point? Okay. 0.184.
Okay, so that would put it as bigger than the level of significance. So wouldn't that fail to reject the null?
Yes.
Mhm.
Okay. What is your conclusion to this problem? So wouldn't it be insufficient evidence that the true population mean is less than 150?
Yes.
The third one?
Mhm.
Yep.
I think so.
Okay. There are two types of errors. Which one involves rejecting the null hypothesis when the hypothesis is true? Type 1?
Yeah.
Yes. Committed when we reject a true null hypothesis.
Okay.
Okay. The researchers decided that level of significance will use one which of the following will be true. Oh, I remember him talking about this in the video.
Is it B?
Probability of type 2 error will increase. Yeah, I think you're right. I know it's like inversely
Yeah, because I thought if it was the type 1 that the type 1 would decrease, so maybe then the type 2 would increase, but I don't really know.
Yeah, I don't know. I don't know.
No, that sounds right. I'm just not. I'm trying to look for it, but that does sound right. Okay, yeah. Well, let's see. Type 1 error will be small. Type 2 error will be large.
Oh,
Okay, so
so is that saying that the type 1 will increase? Or, no, type 2 will
Um,
increase?
so if you decrease the level of significance, I just can't remember which one increases.
Let's see right here. If we want to decrease the probability of making a type 2 error, we would need to increase the level of significance.
All right, so if we decrease, well,
Because we decrease the level of significance, so would that increase the error?
what did you say just now, Rachel?
If we want to decrease the probability of making a type 2 error, we would need to increase the level of significance.
So then, yeah, I think you're right, Jenna. I think it is that the probability will increase
yes, that makes sense.
because they flip-flop.
Mhm.
So if he decreased the level of significance, it would increase. Okay, we forget about that.
Oh,
I
sorry,
think we're good.
that's type
What did we decide?
increase.
I think what you said, the second one.
Okay,
Okay, so if a
last question.
probability of committing a type 1 error.
Ugh, I remember
Oh.
this from the homework. It's
Oh, I don't remember how to do this.
I don't either.
how to do this.
I haven't done the
I
homework.
forget, I only did the preparation and I didn't see this in the preparation.
Okay, so
Did you watch all of the videos? Because it was in one of the videos. But there
I
were
just-
like tons of videos this week.
I just watched the video that went with the prepper.
Yeah, I don't think it was in that one. I think it was in the math one that guy did. Let me see. Wait, so we're trying to calculate the probability. So let's just the z equals the x bar minus mu over standard deviation over square root of n.
Uh-huh.
Hold on, say it again.
And then you put it into the applet. So it's not. So okay.
So you do for the information part.
Wait, well, isn't it actually just stay at 0.05? That's the answer. 0.05. You just saying? Because that's what like the alpha means. that's the percentage that you're going to get one of these errors. Am I echoing? I'm echoing.
You're echoing. Shoot.
The type 1 error variable. Why can't I actually say that? A type 1 error indicated when we reject the true null hypothesis.
Okay, I think it's going to, I'm just going to submit it. Sorry that I'm echoing. Yes, that's right.
Oh,
So it's just 0.05?
5, yeah. It's
that's
5%.
easy. Was everything else right too?
Yep.
Wow, good job, guys.
Nice.
All right.
My kids are screaming. I can hear them. See you guys later.